Summers' microphone on, so I'm good. Summers, that's good. Like if that's like that, okay. All right, so a piecewise function is a function. Oh, don't do that. With smaller functions at different parts of the domain. What values represent the domain? So what values represent the domain? Do you remember? Yes, the x values. So what this means is we have a graph that has different parts of the x will have a different kind of line. So I don't know if you've ever seen like this right here. The graph has different kinds of lines all over it, right? So remember last time we had absolute value functions. Didn't the absolute value functions look like a V? Do you remember that? When you graphed an absolute value function, it ended up looking like a V, right? So we could think of an absolute value function as a piecewise function. We can rewrite it to say that all values for f of x equals the absolute value of x, all values of x less than 0 give you this line. Oh, we'll highlight it so it looks prettier. Gives you this line.
Guys, I'm going to pass this stapler around class in case you want to staple today's notes to the back of the unit packet. Okay? What's the packet? The one with the days, green. The one that's also
All of the notes.
Well, that was your choice.
I know I didn't staple them.
Okay, so then all the values of x greater than 0 gives you this line here. So we can see how a piecewise function is a graph that for certain values of x, you have a different line, right? So we're going to skip this part right now. Let's go to this page here. Thank you. Here's the, oh, just have it else. Did you take the notes, Summers?
I don't understand.
Did you take the rest of the
I do
notes?
not understand.
I got it. Yeah. I was organizing.
Oh, okay. Zeke just needs them. Zeke, the notes are right here. Do you guys want to grab colored pencils? Get three different colored pencils quickly, and then go to your seats. There's a drawer. Which drawer is it?
Right here. Quick.
Okay, that drawer. Quickly
Four
grab
markers.
three
Or if you
different-
already have colors.
Grab three different
Highlighters.
colors.
4.1? Oh.
Quickly grab pencils. We can worry about circling it in a minute.
Everyone was stapling.
Okay, back table, do you guys have 3 colored pencils? AJ, do you have 3 colored pencils? Okay, go get 3 colored pencils. Yeah, we need it.
Boom! Stapled.
Landon, Taylor, Libby.
Do we need 2 each?
You need, well, I mean, you could share if you want to.
Okay, we're sharing.
Yeah, go get 3 colored pencils and then swap them when I say swap. Well, you need, all right, that's fair. Okay. So this is a piecewise function right here. Not that. Hello. Okay, this piecewise function, all right, up here. This piecewise function has 3 different parts to it. So these right here are called restricted domains. So when we are trying to fill out this table, these restricted domains tell us where we're going to put our x into the equations, okay? So the first thing that we're going to want to do is draw a number line. If it's too hard to share those, you might want to just go get more. The notes are underneath this green paper right here. And then everyone has 3 colored pencils. So there's like the thing with the color. Do you have notes? Okay, so we want to look at these restricted domains to know where we're going to put our values, okay? The first number we see is this -2. So we're going to write -2. And then we want to end with this number, +2. And then you can write in the rest, -1, 0, 1.
How did you get that?
So I look at the first restricted domain, and it gave me x is less than -2. And the last one gives me the highest number, which was 2. So our number line has all of those numbers.
Okay, but why aren't we using the ones inside?
So first we just want to know where these parts of the function go on the graph. So, or where on the number line does it go? So we know where we're going to put the -5. So looking at x is less than 2, where would you put that on your number line? Okay, so it's going to go to the left, and then what did you say?
Right between -1 and 2, or
So not right between, but at the
at the -2.
-2. So do you remember if this should be a closed or an open circle? How do we know if this is a closed or an open circle? Open. Yeah, so that's going to be a closed circle, but how do we know if we color it in or not? So you're going to know by this inequality sign. What is this inequality? Oh, you know it. Yes, if this has a line under it, then it's closed. If it's no line, then it's open. So this one is an open line. start at -2 and you go to the left because the arrow is pointing to the left. Or it's less than. Now the middle one, what are the numbers for the middle one?
Close to the left.
Yeah, so it's closed at -2. So we're going to draw a little dot up here. And then what's the other side? So there's the -2. And then the right side is just 2. Is it also closed or is it open? Closed. And this symbol right here means that x is greater than -2 because remember you have to look at where the x is and the alligator is eating the x, so it's bigger. X is greater than -2 and less than +2, so it goes right in between.
So it stops at -2.
Stops at -2 because it says greater than or equal to -2, so it's more than 2 or equal to. Okay, now you guys tell me where am I going to put the last one? Is it the negative or the +2? Yeah, +2, and then go to what direction? Where the arrow is pointing, yeah. To the right. Now, is this an open or a closed circle? Open. Good. Good. Okay, so this is going to tell us where on the number line these numbers go and which function, subfunction, we put it in. So the -5. Where's the -5 on this number line? Were you answering? Where's the -5 on the number line? To the left. So it's over here. Here's a -5. So that means it's going to go with the blue, right? Do we see what I'm doing? Okay. So the -5 is going to go into this blue equation. So this is a g. The g of -5 equals -5 plus 1. So I took this -5 and I put it in for the x.
What do you put D first? Oh,
That is the name of the function. This is the function notation that we learned. Yep, negative, parentheses, -5. So this is like -1 times -5. What is the answer?
don't you have to do the other one? Like,
Well, let's solve this one first. 6. All right, what about -1? Where is that going to go on the number line? At the -1. Yep. And then you said in this second section. Here's our -1. So we're going to use green, or your second color. Say g of -1 equals, here's our equation, -1 squared. Yay! AJ, what is -1 squared? What is -1 squared? So it's -1 times -1. Mm-hmm. Positive 1. Aiden, where are we going to put the 0? Where on the number line does the 0? Is the 0?
In the middle.
In the middle. Is it in the blue, green, or yellow section then? So it's in the middle.
Oh, green. It looks like yellow.
Oh, you're right, it does. Here, this is darker. Okay, so then we're going to do g of 0 equals 0 squared.
Why wouldn't you do like
Which one? The green one twice? Yeah, because the negative 1 and the 0 are in the green.
is it 1 and 2?
What? So negative 2 is an open circle for the blue and a closed circle for the green, so it would go in the green. Okay. 0 squared is, everyone say this? Wait, everyone say this? 0. Okay. Which one? Okay, we're good? Okay. Okay, what about 2? I see 2 in both of these, but which one am I going to use 2 for? Why would you choose the bottom one for the 2?
It's positive 2. It's open circle.
So what does the open circle mean?
It means it doesn't have, it's not equal to.
Not equal to. Good. So if the 2 is not equal to the x there, where's 2 equal to? In which one of these equations? The second one. Yeah, did you guys hear that? Yeah. Why would we use the second equation? Someone from this table. Why would we use the second equation for x equals 2? And not the third?
Because it's the positive 2 at the end.
Yeah, so it's the positive 2, but I see the yellow touches that and the green. Why would I use the green, not the yellow?
It's an open circle.
Yes, because the yellow is the open circle.
Yeah.
The equal to is with this equation. I just erased it.
Oh, can I
Yeah.
make it? I'm sorry. Do you mind?
No, I don't mind.
You know what I just realized I think would help, and this is my bad because when I was, and I want to tie in what we're doing today. First of all, sometimes I think it helps you guys. What we're learning today is some of our hardest stuff all year. Okay, piecewise functions are some of the hardest stuff. So if you're struggling, it's literally, this is just really hard stuff. Piecewise functions is probably top 3 most difficult things we learn all year, okay? So the last couple class periods were in preparation for this, okay? Why can't, okay, hold on. If I have more than one, I think this will help. Everybody listening? I'm a teacher, so I need attention. So I need you to look at my face, okay? Okay, so why, if I have more than one equation, why can I only use one at a time? What's something we've learned in previous lessons in this unit that I totally didn't even think to bring up in A1 that I think will help? Why can't I use more than one of those equations at a time? What would happen? Think about what we learned in the last couple classes. To make a function, what has to be true?
It's vertical line.
Vertical line test, there you go. So the reason why you have to decide which of the 3 ones to use at a time, right? Because I can't use more than one of them at a time because then it wouldn't pass the vertical line test. Remember that? Like if there was 2 closed circles at -2, couldn't I have 2 possible things that could come out of my vending machine if I press -2? Does that make sense? So what she's doing with the different colors is showing you that we can only use one of the 3 equations at a time, or else it wouldn't be a function, it wouldn't pass the vertical line test. Does that help? So it's one function, but the different colors are saying at which time should I use green, yellow, or blue right? Because I can't use more than one color because then it's not a function. It wouldn't pass the vertical line test. Does that make sense? But stick with it, you guys. Those of you that are focusing are doing really well. This really is just tough stuff, okay? So keep it up. You're doing good,
Yeah.
okay? I wonder if we bring that up in A1 next time, if that'll help too. I just didn't even think of it until just now.
Yeah. Totally. Yeah. Okay. So the 2 can't go in both of these, like she said.
I was ready. He hammered it.
Why would you do
It's
that?
okay. I'll sharpen it for you and I'll take it.
Okay, back up here.
Actually, I have another one.
So the 2 can't go in both of these, so it needs to go with the one that has the equal to. So 2 squared equals 4.
We'll do it after class. Zip it. Okay.
Can I write down?
Where are you? No, orange. Okay. So where's our 6 gonna go? To the right. It's the yellow one. G of 6 equals the absolute value of 6 minus 3. Which equals, Dylan, what is absolute value of 6 minus 3? What does the absolute value mean? Can someone tell me? Huh? It's positive. Means take the positive of it. So the positive 6 minus 3, Dylan, what's 6 minus 3? 3. Good. You good? Yes. So now I'm going to make your day for all of you that have calculators. Show you how to solve this on a calculator. Yep.